Most of the compounds that you encounter in general chemistry are binary, meaning they're made up of two types of elements. And usually they have the general formula AXN, where you have 1 of the first element and N number of the second element. When you're trying to draw Lewis structures of compounds with this type of formula, there's a method you can use that usually works regardless of whether the compound is neutral or a polyatomic ion, or whether one of the atoms is an exception to the octet rule. When we use this method, we assume that A is the central atom and the X's are the outer atoms that are bonded to A. Let's use phosphorus trichloride as an example. The first thing we're going to do is count the number of valence electrons that we have. And remember, using the AB grouping system that we usually use in general chemistry, for the main group elements, the A group, the group number equals the valence number, the number of valence electrons. So phosphorus is in group 5. It contributes 5 valence electrons to this compound. The 3 chlorines are in group 7. They each contribute 7 valence electrons, giving us a total of 26 valence electrons that we have to show as either bonds or lone pairs. Next, we're going to connect the outer atoms to the central atom, starting off with single bonds. Don't worry about multiple bonding yet. So hooking those 3 chlorines up to that phosphorus in the center requires 6 of our 26 valence electrons. From here, we start using up our remaining electrons as lone pairs, starting with the outer atoms. And if you counted correctly, you should have enough to give your outer atoms 3 sets of lone pairs to complete their octets. At this point, we've used up 18 electrons as lone pairs. That leaves us with 2 more, and we'll put those on the central atom, which uses up all 26. At this point, you'll want to check the octet rule to make sure that all of the atoms that require 8 valence electrons have them. Here we see that all 3 chlorines have 8 valence electrons through 3 lone pairs and 2 from a single bond. Phosphorus has 6 electrons from single bonds and 2 electrons from a lone pair. So at this point, it looks like everyone has their octet, so there's a very good chance that we're done. Now let's look at a polyatomic ion, nitrate. Again, we start with our valence count. Nitrogen's in group 5, so it should contribute 5 valence electrons. Oxygen's in group 6, so each one of those should contribute 6 electrons. But nitrate has a -1 charge, which means it's picked up 1 electron somewhere. That electron should be factored into your valence count, meaning our total is 24. Next, we'll connect our outer atoms to our central atom using single bonds, which takes care of 6 of our 24 electrons. And the remaining electrons are added as lone pairs, starting with the outer atoms. And in this case, once we give our outer atoms their octets through 3 lone pairs, that actually uses up all 24 electrons. But when it's time to check the octet rule for everyone, the central atom comes up short. It only has 6. And nitrogen isn't an exception to the octet rule in this case. It needs its 8. So how do we give nitrogen 8 electrons but still keep our original count of 24 electrons? Because remember, you can't add or remove from this count. This is where we start thinking about multiple bonds. What we'll do is take a lone pair from one of our oxygens and convert it to a shared pair, a bond. That way the oxygen still has 8 electrons, but now nitrogen has 8 as well. And we still have 24 electrons overall. Now when we check the octet rule, all of the oxygens have 8 valence electrons, our nitrogen has 8. Looks like we're done. Finally, let's look at sulfur tetrafluoride. Again, we start with our valence count. Sulfur's in group 6, it should contribute 6 electrons. Our 4 fluorines should contribute 7 apiece because they're in group 7, giving us a total of 34 electrons. Just like before, we start by hooking our outer atoms up to our central atom using single bonds, which takes care of 8 of our 34 electrons. Next, we add lone pairs to the structure, starting with the outer atoms and giving our 4 fluorines their octet by way of 3 lone pairs. That uses up 24 valence electrons. Now you might think we're done at this point because all of the atoms seem to have their octets. But if you add up the number of valence electrons shown, it only adds up to 32. In a previous example, we said that any remaining electrons should go on the central atom as a lone pair. This gives sulfur more than 8 electrons, but remember, as long as the atomic number is 13 or higher, it's okay to have more than 8, what we normally call an expanded valence. So we'll keep those 2 electrons there, and that uses up all 34 electrons. So as you can see, this method works really well for finding the Lewis structures of compounds that have the general formula AXN. and it usually works regardless of whether or not the compound is neutral and everybody obeys the octet rule, or whether you have a polyatomic ion, or one of the atoms is an exception to the octet rule.